And next topic is types of data structures. And regarding these types, it is very much important, types of data structures. So broadly, types are classified into two. One is primitive or primary data structure, and other type we call it as non-primitive or secondary data structures. Okay, primitive or primary data structures, non-primitive or secondary data structures. So under this primitive or primary, we call it as primary data structures, we have built-in data types. You might have studied C, C++, Java. So there we have the term called data types. So which comes under primary data structure. Your primary data structures are nothing but our inbuilt data types like integer, character, float, double, pointer. So these are all coming under which category? Primitive or primary data structure. So this is one type of data structure. And the second one is non-primitive or secondary data structures. So again it is split into two categories like linear data structure and non-linear data structures. So these two data structures are very much important. These two types are very much important, like linear data structure, non-linear data structure, linear and non-linear data structure. So your linear data structure has so many things like array, stack, queue and linked list. And your non-linear data structure contains trees, graphs and maps. Okay, so these are all the types of data structure. Once again I'll repeat, our data structure is divided into, broadly classified into two types. One is primitive data structure and another one is non-primitive data structure. So our primitive data structures are nothing but our built-in data types, integer, character, float, double, pointer. And non-primitive, it has two important data structures. One is linear and non-linear. So linear is list like array, stack, queue, linked list. And non-linear, so under this we have trees, graphs, maps, etc. Okay. So this image shows types of data structures. This is an examples of types of data structures. We have discussed two types like linear data structure and non-linear data structure, right? So these are all the examples for linear and non-linear. So linear means arrays, linked list, stack and queue. Non-linear is trees. Tree data structure will be like this and graph data structure will be like this. Okay. So these are all the examples of data structures. Let's see a detailed explanation of types of data structures here. The first we discussed about primary data structure, or we call it as primitive data structure, which is nothing but what I told you, inbuilt data types. So it is like a data structure that can hold a single value in a particular location. Some of the common primitive data types of integers, characters, real, boolean, float, etc. And secondary data structures, or we call non-primitive data structures, or the non-primitive data structures is a kind of data structure that can hold multiple values either in a contiguous or random location. The non-primitive data types are defined by the programmer. So based on their needs, the programmer will define this non-primitive data structures. So the next type is linear data structures. So the linear data structure, the name itself implies that all the data elements are arranged in linear, that is one after another order, sequential order. Example of array, our list data structure, that is we arrange one after another, like array, stack, queue, list are some of the examples of linear, that is sequential, that is the data will be arranged in a sequential manner, one after another. And next is non-linear data structures. So it is like it is not arranged in linear manner, but it follows some hierarchical order. Okay, parent-child relationship, something like that. So like we say it as trees, graphs comes under this category. And next is some of the applications of data structure. So where this data structure is used in real world scenario. So it is used in compiler design. Just to build your compilers, we usually compile our source code, right? For building that compiler, this data structures is being used, and for operating systems and also for database management systems, the data structures are used, and computer graphics. So it is also using data structures, artificial intelligence, networking, simulation. So mostly it has so much of applications. The data structures we are using everywhere. So whatever the application we create, at least one type of data structure we will be using. Like for example, let's say if we are going to add two numbers, then there also we have to define which type of data it is, integer, float or character. So integer, float, character, it comes under what? Primary data structure again. So whatever the application, whatever the thing we are going to do, obviously we are going to have this data structure. We are going to implement with the help of this data structures only.